Stan Gibilisco here. I just thought up something kind of interesting. Today is January 6th, 2013 or 2013. It's the day, twice a month, I test my emergency generator. And I just thought of an interesting experiment that I'd like to do, and when and if I do it, I'll put up a video that explains the results and whether or not they agree with the theory that I have here. There's a well-known test that you can do using a voltmeter, an AC voltmeter, to see whether two different outlets in your house are in phase with each other or out of phase. Normally, in the United States, the household voltage is approximately 117 volts RMS, root mean square. And household circuits are split into two phases. They are out of phase with each other. If two outlets are in the same phase, then the hot slots, that's these right here, will produce waves that are in phase with each other. So, in theory, if you connect an AC voltmeter, now when you do this, you need to be sure of a number of things. You need to be certain that you wear rubber gloves and rubber-soled shoes. You need to be sure that the voltmeter can measure at least 250 volts full scale, and you need to be absolutely positively certain that you set that meter to measure volts, not amperes, not ohms. A multimeter will do the job, preferably an analog multimeter, but a digital multimeter will also work for this particular experiment. If these two outlets, you pick two outlets in your house in different rooms on different breakers, and you run an extension cord from one outlet so that it's near the other one, so that you get, here's the extension cord outlet and here's the wall outlet, and they're near each other, and you put the probe tips of the voltmeter into the shorter slots, the hot slots, and you measure the voltage between them. If these two outlets are the same phase, you'll get 0. But if they're in opposite phase, then the relative phase, the waves buck each other. You've got one wave going like that. You've got the other wave going like that. So what you're measuring is the difference between them, which can peak at up to twice 117 volts, approximately 234 volts. So you're either going to see about 234 volts, that's bucking phase, or 0 volts if they're in phase. Okay, fine. We know that these are both going to have exactly the same frequency. Their phase may be the same or it may differ, but the frequency will always be 60 hertz in the United States. 60 hertz or 60 cycles per second. So we're going to make sure that these waves are either following each other along or else bucking each other like that. Well, I began to wonder, suppose that instead of another household outlet, I use my emergency power generator output for one of the outlets and one of the home outlets for the other one. And then I connect the voltmeter up. Now, We don't know whether they're going to be in phase or not. We don't know how much the phase difference is going to be. And we can be pretty sure that the frequency of the generator is going to differ just a little bit from the frequency at the outlets in the house. So what I'm thinking is going to happen with this AC voltmeter right here, if we connect an analog meter up here. Now if we connect a digital meter, we're probably going to get a jumble of numbers that keeps changing. If we connect an analog meter up here, my theory is that the meter reading's going to bounce between 0 and 234 at a rate equal to the frequency difference between these two signals, for lack of a better word. Again, we would measure AC volts. This afternoon, if I can remember to do it, when I test my generator, I'm going to try this, and I'm going to see whether or not that's what happens. Now, if the difference is too great, too many hertz, like say 50 versus 60 hertz, that meter needle is going to be moving so fast that it's probably just going to quiver. But if it's real close, like within a hertz or so, I'm expecting that that needle's going to bounce like that. So I'm waiting with bated breath to see what's going to happen. Stan Gibilisco signing off for now.